So in this video, we will discuss how to do subtraction of two numbers with complements. The motivation of using complements is written here. The direct method of subtraction using the borrow concept, which we have discussed in the previous class or previous video, the link I would provide, works well when we perform it on paper and pencil. However, when the same process which we discussed of borrowing, we try to implement it with digital hardware, the method is less efficient. That is why we use the method of complements. What is the method of complement? For that, we will first understand the concept of first complement of any n-digit number A which is in base R. So just read the definition that R's complement is the radix or the base of any number which is used to represent that. As we know, we can use decimal uh, base or decimal radix or binary radix. So R's complement of any n-digit number is base R is defined as 2 to the power. I should not write 2 here. I should write R to the power n minus a. Okay. For example, we want to represent 153 in tens complement form because 153 is in decimal and we want to write it in as tens complement form. The answer would be 10 to the power 3 minus 153. And if we do it, we'll get 847. Similarly, each complement of 1 to 1, which is a number, 1 to 1 is a number written in base 3. So if we solve it and we get the answer as 102, one can say that this job is also tedious, that we have to subtract it with r to the power n. But there is a very simple method in order to find out the r's complement of a number. So we just look back the tens complement of 153. What we do, we subtract each digit by 9. We subtract each digit by 9, and then whatever resultant we get, we increment it by 1. Similarly, for to get this complement of 1253, we subtract each digit by 2. Each digit by 2, subtract each digit by r minus 1, or in this case 2, and whatever resultant we get, we will get 101 in this case. Whatever resultant we get, we increment it by 1. Similarly, we can find out 2's complement of this. For that, what we can do, we can use the direct method, that we can subtract it with 2 to the power 5. We can subtract it with 2 to the power 5. This, in order to subtract, we will use the same method which we did the concept of borrow. So for this, we have to subtract it with this number, right? 2 to the power 5 means this. One, two, three, four, five. 1, 2, 3, 4, 5. Yeah. So instead, what we can do, we will subtract each digit by 1. R minus 1 means 1, and then we will increment the resultant by 1. Let's see it. So if we just subtract each digit by 1, we will get 0, 0, 1, 1, 0, and then we increment it by 1. We will get the 2's complement of any binary number. So this is how we get the r's complement of any number. So as we said that we will do the subtraction with the help of the complements and with the help of r's complement for our scenario. So we want to subtract two digits of n number in base r, right? Then we have to follow these three steps. What is the question? Our question in hand is that a is a number in base r. You represent a. I would write it like this, that a is any number, right? You can represent it in some base r. We'll see this an example. First, let's understand these steps. That if you want to add a with, subtract b from a, what we do, instead of doing the subtraction using the borrowing method, we will first add a to the r's complement of b. The step one is to add a with the r's complement of b. This is the r complement of b. So if you do that, the resultant will be this. So the output of the first step is this. So if our A is greater than B, we'll see that the output of the first step or the sum we have performed, the output of the summation will produce a carry, right? Will produce a carry which can be discarded, right? And once we discard the carry, if we discard this term, this is carry, we will get the answer. What is left is the result, A minus B. This is the case when our A is greater than B. But what would happen if A is less than B? If A is less than B, then the sum will not produce carry. But what would be the output? Output would be, you can write this, the output is same as this, r to the power n minus b minus a, right? This is positive, right? So the number will be less than the sum. There will be no carry, right? Because there is no nth power of r, right? So when there is no carry, what we have to do, the answer whatever we are getting is not the actual answer but r's complement of b minus a. So when our a is less than b, what we are having, this is, you can see here, this is r's complement of b minus a, right? But our aim is to get a minus b. So for that, what we'll do, we'll again take the r's complement of this number. So what would be the output? The output will be b minus a. Correct? So if we put a negative sign before that, the answer will be whatever is required. We wanted to do a minus b, so we will get a minus b. So let's understand these steps with an example. With examples. First example is our a is 72532 in base 10 and b is also in base 10, 3250. So as we said, that we have to in order to subtract, or the subtraction of two n digit numbers, right? So the same number, the two numbers should have same number of digits. So for this we append 0 before 3250. So now both a and b are of 5-digit number, right? So what was the next step? The next step is, rather doing the borrowing method, either you can do the borrowing method which we have studied in our elementary school. You can do the subtraction easily. But here we are following the complement method. So for this we'll add a with 2's complement of b. So here this negative operation, this subtraction operation will become addition operation in 2's complement domain. So we are adding a with the 2's complement of b. We will get this answer. If you add it, you will see this is carry. So if we ignore carry, ignoring carry means just subtracting it with 2 to the power n, right? As I said here, when you have carry, means if a is greater than b, you will have r to the power n plus. So you have to remove this, right? So this is what we are doing, just remove it, remove the carry. So this is a 1, 2, 3, 4, 5. 1, 2, 3, 4, 5-digit number, and if you get 6 digit, just ignore that 6 digit and you will get the answer. The answer is 69282. You can also check it from here. So the answer is right. This was the satisfying our case 1 when our a was greater than b. So we get a carry when our A was greater than B. Now let's, in example, we just invert the example we took in right? We just discussed. So here our A is 3250 and B is 72532 and B is 72532. So we want to subtract it. What first? The number of digits must be same. So we just put a 0 here. So now we do it in the 2's complement domain. Instead of subtracting, we will add A with the 10's complement of B. Here I have written 2, so please correct it. It should be 10 complement. 10's complement of B. So we will add these two. We will get 3078. Here we are seeing that there is 1, 2, 3, 4, 5 digits, and here the answer is also having 5 digits. So there is no carry. So what we have to do when there is no carry? In fact, what we are getting the tens are the r to the power n or tens complement. This is the tens complement of b minus a, right? So tens complement of b minus a. So we again take the complement, so we'll get b minus a, but we want a minus b, so we put minus also. So what you have to do? You have to first take the tens complement and put a minus sign, minus 692. So of course this should be the answer, right? Because a minus b was this, so b minus a would be minus of this. Similarly, you can do the subtraction in binary domain. X is this and y is this number 1000011, and we want to subtract it, right? So what we do, we do go to complement domain, and in complement domain subtraction become addition. So we'll add x with the 2's complement of y, and once we add it, we'll see that we are having a carry, so we'll reject it, because 1 2 3 4 5 6 7, there is 7 digit in x and y, right? It's 7. So we are having a number more than 7, right? So this carry is called carry, so we'll discard it, right? So once we discard it, we'll get the answer. You can also repeat this with y and x, and you can see then you have to take the 2's complement, and then because if you just revert this and we take y as y00011 and x as 1010100, and we try to subtract x from y, we'll see here that we will do it by yourself, and we'll see that there will be no carry. And once there is no carry, whatever answer you get from this x, you have to do this. I'm just explaining the steps. You have to write y like this. You have to write 2's complement here of x, add it. You will see there will be no carry. Okay, let's do it. So 2's complement of this can be written as just invert each digit and then add it by 1. So 1010100. So 2's complement, in order to get the 2's complement of this, either we have to first subtract each digit by 1. Subtracting each digit by 1 is equivalent to inverting each digit, right? 1 1 0 1 0 1 0, and then adding it plus 1. So once we add, so 1 and 1 0, we get some carry 0 and 1, and then 1 0 1 0 1 0 1. So you will get 0 1 0 1 1 0 0. So as you can see that 1 2 3 4 5 6 7, 1 2 3 4 5 6, there are 7 digits, there is no carry. So whatever answer we are getting the 2's complement of y minus of x minus y. So this is 2's complement of x minus y, 2's complement of x minus y, because we have seen here that answer we get 2's complement of b minus a, but we want y minus x, so we'll again take 2's complement of the answer. No, we have to do one more thing here. Excuse me. So first we are writing here 0, 1, 0, 1, 1, 0, 0, and then we have to add it. So once we add it, 1, 1, 1, 1, 0, 1, 1, 1, 1, 0, 1, 1, 1, 1. So as you can see, there is no carry. So next we have to take 2's complement of the answer. So we have to take 2's complement of this, then add it with 1. So this is 2's complement of this, this is 2's complement of this, and then we have to put a minus sign. So the answer is minus 0, 0, 1, 0, 0, 0, 1. Okay. So y minus x would yield this. Just verify this. If any you find any mistake, please let me know. And thank you.